All right, friends, Mr. Burrell here. This is the very last lesson for this unit. We've talked about quadratics in standard form, how to change them from standard form to vertex form, and how to change them from standard form to factored form. We've talked about lots of other aspects of quadratic functions, parabolas, what the graphs look like, how we can find out where the graphs are located, how to find the vertex, how to find the x-intercept, how to find the y-intercept, how to find all these different things. This last thing, this last lesson, this last concept, we're going to talk about changing to standard form. So whether a function is in factored form or in vertex form or some other form, we're going to talk about how to change it back to standard form. So you can kind of come full circle. Any form that a quadratic function is given to you in, you can change it to any other form in order to be able to identify the things that you want to identify, like the axis of symmetry, or the x-intercepts, or the y-intercepts, or the vertex, etc., etc., etc. So, one objective by the end of class today, given a quadratic in any form, I want you to be able to change that equation to standard form. Okay, so remember what standard form is. If I have standard form is going to look like this. Y equals ax squared plus bx plus c. That's standard form. If I'm given something like this, y equals x minus h squared plus k, that's going to be in vertex form. If I'm given something like y equals x minus r and x, or x plus r and x plus z, I don't know, if I have two factors like that, that's going to be in factored form. So those are the three main different ways that you might see a quadratic function written. So, when you are given a quadratic equation in either, in either vertex or factored form, you can change the quadratic back into standard form by simplifying, or by multiplying back together terms that have been factored, combining like terms, etc., etc., etc. So this, what we're about to do, isn't really new information. Back in the first trimester of Math 2, when we talked about multiplying and adding and subtracting polynomials, we've already done this. But let me walk you through what this would look like. So here is a quadratic function in vertex form. So right off the bat, I could tell you that the vertex of this function is 2, 5. The axis of symmetry is at x equals 2, etc., etc., etc. There's some things that I could tell you right off the bat about this function when it's in vertex form. So what I want to do now is I want to convert this into standard form. So here's what I'm going to do. So I have x minus 2 squared, this term right here. So I'm going to square the x minus 2 term, or in other words, I'm going to multiply x minus 2 times x minus 2. So there's two ways you can go about thinking about this. Some of you really like the box method, where I'd set up this 2 by 2 box, and then I'd multiply all of these terms together and get x squared, negative 2x, and a positive 4. Or some of you like using the rainbow method, and you'd get x squared minus 2x plus 4, which simplified would be x squared minus 4x plus 4. Okay, so that was this x minus 2 squared term right here. So I'm just going to write the rest of my equation here. I have y equals 3 times that was x minus 2 squared, plus 5. Okay, I'm not quite in standard form yet. I still have some things to multiply together. For example, this 3, I'm going to go ahead and distribute into every single one of these terms. Let me draw a little arrow over here, and I'm going to have 3x squared minus 12x plus 12 plus 5. So I distributed 3 into each of those terms, and I was left with 3x squared minus 12x plus 12, and then I have this plus 5 on the outside. Well, I can combine like terms now, because 12 plus 5, that's just 3x squared minus 12x plus 17. So my final answer would be y equals 3x squared minus 12x plus 17. I kind of did not follow my steps here. But again, step 2 here, the next thing I wanted you to do is multiply the result from step 1 by 3, which I did. I multiplied x squared minus 4x plus 4 times 3 by distributing this 3 into all of those terms. And then I combined my like terms. I added my 5 and my 12 together to get 17. So now that function is in standard form. Now from this form, I could convert it back to vertex form if I wanted to. I could potentially convert it into factored form, etc., etc. Okay, what if I have a quadratic that's in factored form? How would I convert that to standard form? Well, I have x plus 7 times x minus 8. Let's multiply those together. They're being multiplied. Let's multiply them together. Simplify this out. So again, you could either use the box method, x plus 7 times x minus 8. X times x is x squared. X times 7 is 7x. X times negative 8 is negative 8x. 8 times 7 is 56. Or if you use the rainbow method, you could do x squared minus 8x plus 7x minus 56. This should be a minus 56. So then, step 2 says combine like terms. I can combine these x terms together. Negative 8x plus 7x is negative x, so x squared minus x minus 56 would be my final answer. Y equals x squared minus x minus 56. And from there, I can convert that to vertex form or into factored form, whichever you would like. And then we can do all the things, find out all the characteristics about quadratic functions that we've discussed in this unit so far. Okay, and that's all we're doing in this lesson. We're just converting quadratic functions that are either in vertex or factored form back into standard form. Okay, let's look at some examples. So again, the instructions here are write the following quadratic equations in standard form. So here I have y equals 7 times x minus 3 squared plus 4. So using my order of operations, I'm going to have to square this first. So let's do that. X minus 3 squared is the same as x minus 3 times x minus 3. I'm going to kind of bounce back between the rainbow method and the box method for multiplying. So x times negative 3 times x, negative 3 times negative 3. That gives me x squared minus 3x plus 9. Then I can combine these together and get, so I'm left with y equals 7 times x squared minus 6x plus 9. So this jazz right here turned into this jazz right here, plus 4. Okay, well next, again in my order of operations, now I need to multiply this 7 through. So I end up with 7x squared minus 42x. 7 times 9 is plus 63 plus 4. There's plus 4 here on the outside. Now all that's left to do is add and subtract. I'm going to go ahead and combine like terms. I have 7x squared minus 42x plus 63 plus 4 is 67. So there's my standard form of that quadratic equation. Okay, this one right here is in factored form, so they're being multiplied together, so let me go ahead and do that. This one I'm going to do the box method. I have x minus 5 and x plus 2, x squared, negative 5x, positive 2x, negative 10. Then combining my like terms here, I get x squared minus 3x minus 10. That's it. That's my final answer. Again, this last lesson I feel like is pretty straightforward. We're just taking everything we've done before and just kind of undoing it, putting it back into standard form, because standard form is what we often see quadratics in. So we want to get used to seeing them in this form and converting between all these different kinds of forms. Okay, let's do another couple examples. So here, if I'm converting this to standard form, first I'm going to have to take care of my exponent here. In my order of operations, I have to do that first. So I'm going to take x plus 2 times x plus 2. I'm going to go ahead and do the rainbow method, and I'll get x squared plus 2x plus 2x plus 4, which is, let me rewrite this right here, the x plus 2 squared part is going to change into x squared, combine these, plus 4x plus 4 minus 6. Okay, well, next step, I have this negative here. This negative needs to be multiplied by everything inside of these parentheses. So I'll be left with negative x squared minus 4x minus 4, and then minus 6. There's no more multiplication or division to be done, so next I'm going to go ahead and combine like terms. Negative 4 minus 6 is negative 10. So I have y equals negative x squared minus 4x minus 10. Now in this form I could potentially convert it to factored form, or I could convert it back into vertex form, whatever I wanted to do, whatever was necessary, whatever, depending on what I wanted to find, what I was asked for, I could manipulate that form into whatever other form I needed. Okay, here, I'm going to go ahead and multiply all these together. I'm going to go ahead and start with these sections right here, x minus 3 times x minus 4. Go ahead and use the box method. I'll have x minus 3 times x minus 4. They're being multiplied. So x times x is x squared. This is negative 3x, negative 4x. Negative 4 times negative 3 is positive 12. And then these are like terms, so they're going to be combined. So I'm going to write y equals 2. And then all of this jazz changes into x squared minus 7x plus 12. Okay. Next, this is a negative 2. This negative 2 needs to be distributed and multiplied by everything inside of this parentheses. So I'll have y equals negative 2x squared. Negative 2 times negative 7x is a positive 14x. Negative 2 times 12 is a negative 24. So my standard form of that quadratic is y equals negative 2x squared plus 14x minus 24. And that's it. So again, what we're doing is we're using order of operations to multiply everything together that we can, combine all our like terms until our quadratic is in this nice, friendly, standard form. Okay, let's do one more example. This is an example off of your homework. This is the very last question on your homework. It says, write the quadratic function that has zeros at negative 6 and 13 in standard form. Okay. So, this isn't the only possibility, but this quadratic function is going to have zeros at negative 1, 2, 3, 4, 5, 6 right here, and positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to cross the x-axis in these two places. So it could potentially look like this, or it could be upside down. But we're going to find a quadratic function that would, in standard form, that would cross the x-axis at those two places. So if it has zeros at negative 6 and 13, that means that those factors are going to be, if I add 6 back to both sides, again, I'm kind of just undoing what I've already done. So if I add 6 to both sides and subtract 13 on both sides, I get x plus 6 equals 0, and x minus 13 equals 0. So you notice how I'm kind of like undoing the steps that I've done in the past as far as finding the zeros of a quadratic function. Now my quadratic function might look something like this. Y equals x plus 6 times x minus 13. That would be in factored form. Because notice from here I could find the zeros. I could find the solutions by setting y equal to 0. X would be equal to negative 6. And y would be equal, or x would also be equal to positive 13. So that's in factored form. I want to go ahead and convert this to standard form. So I'm going to multiply these two together by using my rainbow, making sure everything in the first parentheses is multiplied by everything in the second parentheses. And I get x squared minus 13x plus 6x minus 6 times 13 is negative 78. Well, again, I can combine like terms here and get x squared minus 7x minus 78. Y equals x squared minus 7x minus 78. That would be the standard form of that quadratic function that has zeros at negative 6 and 13. And if you wanted to double check, go ahead and plug in 13 and negative 6 respectively in x for each of those. 13 squared minus 7 times 13 minus 78, and then negative 6 squared minus 7 times negative 6 minus 78, you should get 0 in both of those equations because these are the zeros or the solutions to that function. That's all I have for you for this video. Again, this one's a little bit shorter than the other ones. It's pretty straightforward, I think. Please don't hesitate. Please don't hesitate to reach out to me if you have any. But hopefully this is what you're able to do by the end of this lesson. A quadratic in any form, however it's given to you, you can convert it to standard form. And then using the tools we've discussed throughout the rest of these past lessons in this unit, hopefully you can convert from standard form to vertex form and a factored form, and in both of those forms, identify some of the characteristics of these quadratic graphs that we've discussed. So I hope that was helpful, and I hope that you enjoyed it as much as I did.